Let's look at an example problem to apply Q equals mc delta T. How many joules are required to raise the temperature of 50.0 grams of iron nails from room temperature at 25.0 degrees Celsius to the boiling point of water at 100.0 degrees Celsius? Pause the video and see if you can answer this. Whenever we use a formula or equation to solve for an unknown value, it is really helpful to take a minute or two to identify what variables we are given. Our equation uses Q or heat, M or mass, C or specific heat capacity, and delta T or the change in temperature. The question asks us to solve for joules, so I know that I'm solving for heat in unit of joules. The mass of iron is given as 50.0 grams. The problem does not give us the specific heat capacity of iron, but if I look at table 1.10 in the text, I see that it is 0.444 joules per gram per degree Celsius. Since I'm solving for energy in units of joules, I want to make sure that I use the specific heat capacity value that uses joules, not calories. The question does not give me an overall temperature change, but it does tell me that the final temperature is 100.0 degrees Celsius and the initial temperature is 25.0 degrees Celsius. Thus, the change in temperature, or final temperature minus initial temperature, is 75.0 degrees Celsius. I can see that I have 3 of my 4 variables and that I'm solving for heat, or Q. Thus, I will use the equation Q equals mc delta T. When I plug in the values for mass, specific heat capacity, and change of temperature, I see that all the units cancel out except for joules. Grams divided by grams is 1, and degrees Celsius divided by degrees Celsius is 1. When I multiply 50.0 by 0.444 by 75.0, my calculator displays as 1,665. Since I multiplied these measurements, my final answer will have as many sig figs as the measurement with the least amount of sig figs. Since each measurement has 3 sig figs, my final answer must have 3 sig figs. Thus, I need to express this answer in scientific notation as 1.67 times 10 to the third joules.